Assalamualaikum and hi. Our project title for MEC 523 is Easy Ventilation. Meet the team: Farhanuddin, Faiz, and Farid. Most of the restaurants' kitchens have ventilation system installed. Installation of ventilation system in a restaurant is very crucial aspect to control the kitchen environment. Proper ventilation ensures the health and safety of staff and also the longevity of the kitchen itself. Heat, grease, and smoke can all offer serious health risks if the kitchen is not adequately vented. Therefore, we decided to install a sensor of temperature. The sensor will detect high and unstable temperature. This sensor is placed at the vent hood. By placing at the vent hood, the sensor will easily detect the temperature captured from the cook line below. Next, we install sensor of smoke. This sensor will detect the smoke produced from chef who is cooking below the vent hood. This sensor will be very sensitive because even it will capture a very small amount of smoke from the kitchen. This sensor is combining together with the temperature sensor and placed at the vent hood.
Now we go into the problem statement. Firstly, a kitchen for a restaurant obviously produces a lot of smoke, steam, grease and odors. Secondly, the steam, smoke, gas, odors and other toxic can slowly give bad effect on the quality of the air in the kitchen. Next, the majority of our exposed to environment pollen takes place indoors. Lastly, a bad ventilation will make the kitchen very uncomfortable for people who work in the kitchen. Our objective for this project is to avoid error and reduce costs by run simulation using Tinker software. Furthermore, we can enhance air ventilation by increase the quality of kitchen environment, and the machine will run fully automatically and it will increase the efficiency of ventilation and will more save energy by run when the machine detects smoke. Now we talk about the components that we used in this project. We used 11 components in this project. Firstly, Arduino, second LCD, temperature sensor, smoke sensor, piezo, LED, wire, potentiometer, resistor, DC motor, and breadboard. Now we go into the costing part for this project. Since we used 11 components, we spent about 54 ringgit 20 cents to run this project. This is the price list of all components for this project.
This is the circuit of our project. We made this circuit by using Tinkercad software. Coding.
Before we go to simulation, let's take a look on the code section for the system. Firstly, we need to declare the LCD is connected to Arduino Uno R3 at pin 12, 11, 5, 4, 3 and 2. These pins should be corresponding with the connection in the circuit to avoid coding failure. Then, we have to declare the component that connected to the Arduino, which are the red LED which connect to pin 7, the green LED which connect to pin 6, the piezo buzzer named buzzer is connected to pin 8, the gas sensor named sensor is connected to analog pin A1. We have to declare the sensor threshold at 400. Then the motor is connected to pin 10.
Simulation.
For the circuit arrangement, we use LCD set, which contain Arduino Uno R3, one small breadboard, one LCD 16x2, one potentiometer and one resistor. Then we add one DC motor, one extra small breadboard, one temperature sensor, one piezo buzzer, two LED lights, 4 resistance and 1 gas sensor. So let's do the connection. The color of wire connection for the power should be red and black, which black will connect to the ground while red connect to the power source 5V. The blue one is input connection from gas sensor to analog pin A1, while the grey wire is for output connection from piezo buzzer to pin 8. Then, the blue input connection is from temperature sensor to analog pin A0. This is our finalized circuit for MEC 523 mini project. We use Tinkercad software to write a code and create a simulation. Now let's take a look on the simulation section. Okay, as we can see here, by existing the smoke, the red LED will be turned on and the green LED will be turned off, and then the DC motor, the speed of DC motor will be at between 4,200 to 5,400 to 5,500 RPM. Next, we can check the temperature sensor. When the temperature is above 50 Fahrenheit, the speed of the DC motor will be at 1,000 to 1,200 RPM. And then if we set the temperature above 130, the speed for DC motor will be at 4,200 to 4,400 RPM. And then the red LED will be turned on while the green LED will be turned off.
3D diagram. Okay, now we move to the 3D diagram. As we can see here, this is the kitchen. How our EasyVenti system operates. Firstly, this red box is containing our circuit, Arduino and other 10 components. The orange one is the connector that containing wire inside it that connect to both smoke and temperature sensor. The green one is a smoke sensor and the blue one is temperature sensor. Next, this thing in yellow color is a smoke discharge. What is inside the smoke discharge? We install an exhaust fan. The exhaust fan will automatically on when smoke is detected from the sensor and will release through the smoke discharge. That's all from us. Thank you for your attention.